about this spreadsheet. So you just saw. Oh, wait a minute. Yeah, you just saw a description of how we get probabilities. Okay, and we use this matrix. We can use this matrix to calculate a net present value, which is down here. Now, I'm not going to go. I don't think you're going to be talking about shutdowns or any of that stuff. If you are, let me know. But what you can do with this, this probability matrix, if you multiply this matrix times the present value of the cash flow matrix, you'll get a net present value. So that, I mean, that's and that number will be this number right here. Okay. But I'm not going to talk about that. Okay. So what I want to do is continue on with the binomial lattice. We've created this thing for the price, so we have a matrix for the prices. We're not going to use probabilities again. These are used only for those things that I talked about before that we won't be doing. And if you want to, like I said, if you want to, let me know and we'll talk about it. So anyway, in the simple case, you had a cash flow, and it was a simple row. But now, and that was based on revenues minus costs. Pretty simple. Okay, now in this case, down here, a cash flow is not a simple row because we have different revenues. Right, so let's take a look at this one right here. So if in year 2 we've gone up 1 and down 1, the price has. Okay, if we look at the cash flow for that situation, we have that price in the second year went up once and down once, times the demand, this thing, just like before, plus the costs in year 2. So the costs are the operating costs, the fixed costs, and then the amortized value of the capacity cost. Right? That's what that cash flow number is. So each of these relates to the price, in this case G72, times the minimum of the demand or the capacity, right, the lower value of those two, and then the sum of the costs in that year. That's it. So in other words, this cash flow matrix gives you the cash flow in any given year under any given combination of circumstances that got you there, right? Ups and downs of the price. And then this next matrix, I've cut it down to only 6 because of the number of the complexity of this. So if I look at the present value of the cash flow matrix, say this entry right here, it's basically just the discounted cash flow of its corresponding element up there, right? So I've discounted it with a 10%. That was the original discount rate, 10% in cell C20, and H67 is the year number, right? So that's that. So these are the cash flows for all different given situations over the 6 years. Now, what I'm going to do over here is I'm going to calculate probabilities of these various paths over the 6 years. So, for example, if I have over the 6 years, if I have all ups and no downs, then it's the product of right, probability up to the 6 times probability down to the 0, right? How many paths are there in this matrix over here that have 6 ups? Well, you can see there's only one, right? There's only one. If I have, now let's go down to this one. If I have 5 up and 1 down, well, now I have more than just one path that has those features. I have this one, drops in the sixth year, or I have this one, drops in the fifth year, and so on, right? So if I look at these, I have 6 different paths through this matrix that has 5 ups and 1 down. If I have 4 ups and 2 down, so you can see one at a time, or this kind of a thing, right? I mean, you can trace a variety of different paths through this network where you have 4 ups and 2 downs. And actually there are 15 of them, 15 different paths that you could follow through this simple matrix to have 4 ups and 2 downs. Okay, so, and I can do the same thing, 3 ups and 3 downs, and there are 20 of those. 20 of those. I don't want to, and that's why I cut this down to only 6 years. If you had 15 years, think about how many different options you'd have for each of these probabilities, right? Okay. Now this probability over here, I'm just going to mention what it is, but we won't use it again. It's this probability. This is the probability of a path that has 4 ups and 2 downs. This is the probability overall of any path having 4 ups and 2 downs. That is, there are 15 different paths that satisfy that criteria, and so 15 is the count times the probability of any individual. So that's what that is. We're not going to worry about that ever again, right? Unless you want to for some other reason. Okay, so the trick now is to somehow get this into a 2-column figure that I can plot for my Varg curve. So I want the probability column, and then I want net present value column, right? This is the net present value. So for this probability, or say this probability, I have 5 different or 6 different net present values associated with that have that probability, right? 6. So what I would need to do is I'd need to create 5 entries in a column that have a probability of 0.059, and then take these 6 values and paste them right next to it. Now that's tricky because you want to be able to leave this general. So I don't want to just cut and paste values, because then the values are static, and if you change something over here later, it doesn't change the Varg curve. So we want to keep the Varg curve relating to this matrix here. So the way I chose to do it, I think it's an easy way to do it, is to use Excel's advanced functions. So I use this address function, row and column, to retrieve M110. See, M110 is this probability right here. I retrieved the address of this cell right here. And now I can just copy that. See, there's 2 of them in the top. So I copied that like that. I copied these, right? These are that's that copy, and so on. Just copied this formula, and it automatically just goes to the appropriate cell. So this address, S113, is that one. That's the address. So now what I'm going to do is take that address. I'm going to take these things, and I'm going to paste the values of these, just like I said. So this address has 6 different addresses associated with it. So that's what I'm going to do. So I'll paste 6 different addresses for that one. Right, in this, but I'm going to just paste the values because these are cell addresses. Now what I can do, create another column of probability, and I'm going to use the indirect function. So if I do that, watch. See, that says, okay, take the contents of this cell, whatever the contents are as a cell address, go to that cell address and retrieve the contents. So the contents is M110, right? So the contents of M110, remember, is 0.0178. So that retrieved that. And I can do the same thing with the net present value here, right? I'm going to go get the stuff that's inside N110 and stick it in here. That's the indirect function. Okay, so I've created a basic probability and net present value table. Now of course these vary with every time I hit a key because I've got that the random generator for the demand, so the values can change. So what I need to do now is take these values, copy them as values here. So see, these are, if you look at the formula bar, these are just values. These were the values of this column at some point in time. And so once I've done that, I can then sort these by increasing net present value and then calculate the cumulative probability up to 100% and plot it in my VAR curve. There it is. So this is the base case. Now I can do the same thing in doing the same exact stuff using my staged construction plan here. I've got the added capacity if the growth is of a certain amount, and then I can do the same thing. I can copy. I can just take this stuff over here and copy it and paste it into this cell, so long as everything is in the same exact spot. And the cell references maintained, we're all good to go. And then over here, I can take these values. Once again, these are live values. I can take these, paste the values here, create the VAR curve again. And here's the VAR curve for my stepped stage construction. And then I can take the values from the base case in the other sheet and compare them to this one. And you can see that this stage construction was highly superior in this particular case. And that's it.